as well. For anyone on the call who doesn't know me, my name's Mark Mann, and I'm the project engineering manager at Price Industries. My focus is air moving products, which for us is fan coils and VAV boxes. The housekeeping items I want to go through as we continue to have more people filter in is that we do have a chat box and a question box available to us in GoToWebinar here. So in the chat box here, I'm going to start off. I'm going to type in my email, and that's just for follow-up. If anyone wants to reach out after the webinar is completed to me with some questions, or reach out to Buckley as well. Dean Lees is a great point of contact. Their whole engineering team, all their sales staff can field questions on this material and can get you pointed in the right direction with Price as well. If you have any questions on this material that's being presented throughout this presentation, throw it in the chat or in the questions section of GoToWebinar. I'm going to answer those live and on the fly as best as I can, and I'll try to save a little bit of time at the end of the presentation to address that further as well. So speaking to kind of the presentation today, especially actually with work that I've done with Buckley, we identified that one of the biggest struggles for consulting mechanical engineers is the amount of time wasted with submittal reviews, submittal redlining, back and forth of iterating performance over and over again, especially with VAV boxes, with hot water coils. You guys in the Northeast are an engineered market. You guys take your design stuff seriously. We want to dial in water temperatures. We want to dial in pressure drops. We really want to dial in the whole VAV box selection. But the reality is, as much as it pains me to admit it, they're commodity products. They're not engineered products. And so we can't spend a lot of time on that either. And at Price, we've been trying to develop solutions for that, for the consulting engineer, so that we can really optimize the workflow, maximize the accuracy of the data that you're getting from Price and from Buckley, while not adding more time to your workflow. That's the goal, that's the value proposition here. And we have a few really exciting tools to talk about. So the first place I'm gonna kind of direct us to here is a Google search screen. And if you type in engineering toolkit into Google, besides engineering toolbox, which I'm sure everybody on the call has spent time using and looking at, finding equations at some point, the second link there is engineering toolkit software Price Industries. And this is our homepage where all things engineering tools lives. So this is where our toolkit for Excel, which we'll discuss today, lives. This is where our toolkit for Revit lives. And this is where our Ripple HVAC tools, which is the first thing I'm going to start with, lives as well. We have download information. We have really everything you need to kind of get kicked off and started with using these tools. And I want to note too, why Excel, why Revit? Well, a major thing we identified is most engineering firms don't want to download another software pack, don't want another individual, manufacturer's performance software. If we can get things on the web, which is what we're trending towards as well, if we can get things into Excel, if we can get things onto Revit, that simplifies the workflow. It's already embedded in the tools you use. So the first one I want to talk about, the first tool here that's going to help optimize this performance selection for VAV boxes is our Ripple HVAC tool for Revit. So the Ripple HVAC tool is a plugin which you can get from the Autodesk store. You can find it on the Price website. And it has a bunch of incredible functionality. It embeds into Revit in particular. And what I want to talk about today is actually the newest tool, which is unreleased but coming out in the next couple weeks. So you guys are getting a bit of a sneak peek, which is our VAV Auto Select tool. So this is the first thing I want to discuss here today. To get a lay of the land, we have the typical kind of core Revit model that you get, which is a 3-story school. So we have probably 70 to 80 zones in this school. We have different space types, whether it's a library, corridor, classroom, bathrooms, all of that information. And hopefully this is a familiar site for most people. And maybe I'll petition the chat here too. I see we have 11 occupant or attendees in here. Just throw into the chat if you use Revit. Give like a yes or an exclamation mark. I'm interested to know who's a avid Revit user in their workflow. Who's using Revit on a regular basis? Just throw something into the chat. Interested to see how familiar everyone is with Revit. Allison, thank you for your response. Allison's using Revit. So Revit obviously can get used for construction drawing sets, but we're also starting to see more and more design work getting done in Revit as well. So the first thing I want to note with these spaces we have here and these zones is these have all the construction information that we see from the architect. So we have the space type and the square footage, the layout here, these have good quality architectural drawing sets in this example here as well. We have a ceiling already laid out. And what we can also see assigned to each of these spaces, we do have some further information as far as, some load material in here. So we do have the load calculations, which could come from like a train trace and be imported into here pretty easily. We also do have tools. There's many plugins for Revit that do load calculations, but within the Ripple HVAC toolkit, we actually have tools for doing load calculations as well. We also have tools for determining supply, return, and exhaust airflow based off of ASHRAE 62.1 guidance and the ventilation rate procedure that we see prescribed and then utilized in international mechanical code. So that's just a heads up for you. That data is already assigned to this model here and is needed for this next step, which is auto selecting VAV boxes. So I click that auto select VAV box tool there, that screen. And what we'll see is we get this pop-up here that has a number of different pieces of information. So what we're going to do here is select between a single duct box with a hot water coil, electric coil, or cooling only. We're going to make some decisions, such as do we want to provide reheat coils on internal zones, yes or no? Then we're going to make some other decisions here, such as our zone air distribution effectiveness. So for everyone on the call, this uses all of kind of the most widespread ASHRAE guidances for the United States and North America in general. So 62.1 for air distribution effectiveness material. We're going to use guideline 36 for sequencing. You'll see here we also have CO2 sensors, which are an available option that's prescribed by guideline 36. You could do with or without that, depending on the requirements of your market. And since I'm selecting hot water coils, I'm going to prescribe a lot of material for that as well. So what do I want my max leaving air temperature to be? What do I want my pressure drop to be? What's my minimum airflow based off of? So this is kind of the industry minimum, 0.004 inches water gauge of differential pressure. I can put in water temperature data, fluid type information, liner type. This will all impact acoustics. And then I have max discharge and radiated NC values as well. And so I have all this plugged in. I'm going to click batch select VAVs. And while this is calculating here, I want to explain what's going on. This Revit tool is going to essentially access all of Price's actual real lab data, the same lab data that we use to feed our all-in-one selection software, which our reps use for pricing and performance. This is used in the Excel tool, which we're going to look at later as well. And this is what we get audited by AHRI every single year to make sure that we're doing accurate calculations, providing accurate data to the industry. And you can see there, that was pretty fast, about 30 seconds. And now suddenly all of these zones actually have a single duct box inside. So these single duct boxes are a mechanical equipment family. These are actual Price Revit families. So Price SDV hot water coil round inlet, and it's a 12-inch box. Now in this zone here, instead, this adjacent classroom, we can see instead there's an 8-inch box provided. And it goes on, you know, as the size gets smaller, the box gets smaller. And that's because every one of these units has been optimized based off of the parameters that I essentially requested as I was prescribing, you know, what I'm going to need for my design. And this still gets a little bit better, a little bit more exciting. We're going to look here at my price air terminal every instance smart schedule that this is generated. Oh, sorry, that's not air terminal. Air terminal is GRD, which I can show off later. That's terminology that's used by Revit. Instead, I'm looking at the price VAV hot water coil schedule. We can see I have all of the performance data, acoustics, hot water coil data, cooling coil data, or sorry, not cooling coil data, cooling data for air through the inlet, carbon dioxide data, minimum ventilation data, all fully prescribed, automatically generated in a full schedule view for us automatically within Revit. So I'm seeing a question come in here from Bradford saying, are all of the relevant required families pulled into the Revit model automatically via the selection process or with the price add-in? So all of these models, which have been generated, I'll go back to the level drawing here. Every single one of these models, when you download the Ripple HVAC tool, it automatically is going to pull those models from our website as well. It's automatically going to populate and drop them into the center of every zone. So it's going to be embedded within the tool, the access to this Revit family. Bradford, if that answers the question, great. If not, feel free to put a follow-up in there. I'd be happy to address it further. And so what we can see here when I go back to this smart schedule is, you know, I have my inlet and casing sizing. We can see in some cases we have oversized casings, which hopefully some of you on the call are familiar with. I know that's a popularly specified option in the Northeast. That's where we would have a smaller inlet and a larger casing and coil, especially for low entering water temperatures, which you guys see in your market more and more. But what I want to point out too is we have these white headers and we have yellow headers as well. And these yellow headers, what they're actually are is it's that list of data that I prescribed for the initial selection. And the beautiful thing is this is a smart schedule, so I can actually go through and change this data further. So what I'm looking at here, I'm going to look at this second column from the top of my schedule where we have a prep area for the cafeteria. And here we have quite a small single duct box that's been sized. It's not a very big space. So we have a size 4-inch inlet with a 6-inch casing. So that's a standard 4-inch box. But what I can see here is my discharge and radiated NCs, for instance, are 29 and 50. And just as an example, NC 29 for a prep space is definitely good enough. But as an example, I'm going to change this prescribed max discharge NC from 50 to 25. And we'll see a quick calculation, the box has been resized. So now my discharge NC has dropped from 29 to 21. All the corresponding octave band sound power values have been resized as well. If I go check out what's going on here, we can see we've upsized the inlet of the box from a 4 to a 5-inch inlet while maintaining all of the performance parameters that have been inserted otherwise. So this is now a smart schedule that you can go through line by line, check performance, modify performance if needed, and it's going to update the Revit family for you within the model as well. So it's automatically going to update whatever this VAV box is that would have been changed, although the one I just did was on level 1. A couple other cool things I want to note. We can see we have this larger, I believe this is like a corridor kind of lobby type space here. And this is a very large space with a large load. So this is the lobby, and we can see, you know, we're looking at a very high volume of cooling load. So 343 MBH. And one box is not enough for this zone. And we know that through the calculation. It's automatically going to understand the maximum sizing that we can do for each zone based off of for each single deck box based off of the data that you prescribe. And we can see here that we actually have 3 size 16 boxes input here for the single duct units rather than one that can't meet the load. I'm seeing another great question here from Bradford. Bradford, thank you for your questions. Can you set restrictions parameters up front? Like you want no less than a 6-inch inlet on any given box, or do you just manipulate after in the smart schedule like you showed? So there is definitely a lot of stuff that you can prescribe up front, Bradford. So for instance, I can choose whether I want or don't want oversized casings. I can choose whether I want even size boxes only, which I know is actually pretty popular in the Northeast too. We don't see a lot of size 7, size 9, size 5 boxes. As far as cutting a minimum, that isn't something that can be done up front in the tool in this instance, but you could, for instance, go through here pretty quickly and re-prescribe kind of the box you want, or you could even just modify the family and change the size in the model, and that's going to update the smart schedule as well. If minimum sizing, so restriction of 4 and 5-inch inlets, if that was something that was really critical to you, we'd absolutely be happy to look at seeing if we can make that another toggle that we can do. And so the edits are pretty reasonable, pretty quick. But the biggest thing is the fact that, you know, so much performance is calculated so quickly. Other thing which I want to point out quickly, we do have an auto zoning tool. So this is going to break down spaces into smaller zones based off of restrictions and parameters that you would prescribe. That's also being released forthcoming. And so for instance, we do have this corridor lobby, which we can see is automatically divided into 2 separate zones. So one space being divided into 2 zones. And because of that, we can see in this case, we have a single deck box that's sized differently than the 3 above. So a lot of maneuverability here. You know, this is also level 2 only, but I would want to just point out and indicate, I'll pull up another level here. Whether level 2, level 1, level 3, the time it took there, we actually got a single deck box for every single zone. So even this very large space that has a tall facade and high ceilings, you know, in this case, it actually divided it into 4 single deck boxes. So lots of valuable information there, a tool that's easy to download, and hopefully you guys can start to get some use from. If there's any questions, please throw them into the chat for that. I'm happy to address them. We can come back to this later. But now I actually want to pivot to another tool here, which is our toolkit for Excel. So I'm going to petition the chat again, the question section here again. If you use Excel regularly in your design workflow, let me know in the chat. I'm interested to know who's an avid user of Microsoft Excel for design purposes as well. I'll admit, something I've done a lot, something I utilize a lot. Historically, my background at Price was in product design. It was also in research and development. Now I work more on the consulting, customer-facing side, and I see engineering schedules all the time that are based out of Excel. And so what we did was we took the same approach of getting the data that we have in all-in-one, the data that we use in our lab, the data that's certified by AHRI, and we're wanting to get that data into Microsoft Excel for your utilization too. So the toolkit for Excel, which is also available for download, this links to the Microsoft App Source Store. So the Microsoft App Source Store, if you download this, it's going to plug in automatically into Excel. And you can see in the top of the screen here, similarly to that Revit banner add-in, I have a Price Industries banner add-in here too. And functionally, what is this? Well, in the same way that I can type equals sum or equals average or whatever kind of function I would typically use in Excel, now I also have the capability and ability to, for instance, get price.watercoils.capacity. So an actual price water coil function embedded in Excel that I can put into any format, any template that I'd like, that calculates price water coil performance. And so obviously that's pretty cool. The use cases are endless, but we do try to make it a little bit easier to use out of the box than you just going and fiddling around with this until you figure out how to get a schedule configured. So to do that, what I'm going to click here is price single duct units in the top, and I'm going to click create schedule, and I'm going to get this pop-up window here that allows me to select a reheat type. So I'll go water coil again, since we were kind of discussing that already, and a solution method, which in this case I'll choose leaving air temperature. If I click generate schedule here, it's going to run a macro in the background, and it's going to start to fully populate and generate a schedule layout for me. So this is really used so that out of the box we can get high functioning performance. You know, as soon as you download this, you can start to play around with this and understand how it works as soon as you download this. And within a couple seconds there, the macros run, and this is going to start working. So it's also a good time to note that took a second to load. It's a little longer loading than what I'd typically see right now. And the reason for that is GoToWebinar uses a lot of active memory for my computer. I have Revit open in the background. This is a web-based plugin. Both of these are web-based plugins. You have to be connected to the internet for them to work. And also, depending on the specs of your computer, you're going to find that it works faster or less quickly, you know, depending on what your requirements are, depending on the capabilities of your computer. So I do want to note that if you think anything looks a little bit slower now, well, I have a pretty slim laptop, fits in my briefcase. I spend a lot of time on the road, so if you have a heavy-duty design laptop, you'll find that it probably works a lot better. And so what we see here, though, with the schedule, it can be as simple as enter in the blue, data out of the yellow cells. That's the most baseline version of it. That's really the simplest version of it. But there's a lot of data here, which I want to note. I just deleted a heating min and heating max. That's a prescribed schedule value in Canada, and we're big in the Canadian market too. So probably not needed for your utilization. For instance, there's also this allow below minimum airflow value. This is just whether or not we're going to exceed the manufacturer's minimums for cooling. That might not be critical to you. That'd be something that you could take out of your schedule, hide, get rid of, code in automatically. But most of this data is pretty typical. So I'm going to start specifying out a single duct box here. I'm going to zoom in a little bit so hopefully everybody can see. I'm going to put in a cooling maximum of 500 CFM. My minimum, I'm going to make 20% of my cooling max. Since it's Excel, it's pretty easy for me to make these kinds of, you know, quick equations and rules. I'm going to do my inlet static pressure and downstream static pressure of 1.25 and 0.25 inches water gauge. That's pretty typical. Here we can see I have a lot of info for acoustics. So I can choose attenuators, liner type silencers. We'll look at that more later, but not right now. Even sizes, whether I want to prescribe even sizes only. And then we get into the meat and potatoes of the selection here, the water coil data, where I'm going to do a 55, 75 degree entering and return air temperature for my single duct box. I'm going to do, in this case, maybe 140 for my entering water temperature for my single duct unit. Here we have casing and coil capacity options. These might be things you'd want to utilize in a schedule, or perhaps not. You could easily overwrite and kind of take them out of this schedule too, but do I want a standard or an oversized casing? Do I want a standard or a higher capacity coil? That's changing the 10 to 12 fins per inch. And then my coil rows, I'm going to choose 2 here. Now the last thing I need to do is prescribe my leaving air temperature. In this case, I'll do 90 degrees leaving air. And we can see a calculation has taken place. So now all of these yellow cells have populated data. You can see there's a few things to note. Some of these significant figures were actually getting corrected. I don't think anyone wants to specify air pressure drop or fluid flow GPM to significant figures. We actually have an update moving forward for this, which should be coming out in about the next month here. We can see I have all this data that's now been calculated. And the great thing with Excel and the functionality of Excel, it's pretty easy for me to, you know, copy this line, paste it down. I could easily create a rule to iterate up 50 CFM for each single duct box. That's a drag and drop scenario that I can do because it's in Microsoft Excel. You know, tagging of the boxes is something that I can also unfortunately drag and drop pretty quickly using that functionality of Excel. Or I can even do a double click, and suddenly I have 20 VAV boxes from 500 to 1450 CFM. I have real HRI certified water coil data, NC data, leaving water temperature and water pressure drop data, fluid flow data, heating capacity data, optimally sized or kind of automatically sized terminals, and all of my air pressure drop as well. So hopefully that can start to show off how powerful this software is. The intention is all of this data is now at your fingertips in a format that you can use as a consulting engineer without the need for turnaround times to get selections made or modified. This is something that you could do as a quick hit turnaround, number for yourself, a plug and play number for an initial schedule. By all means, if you still want to always operate through Buckley, which I wouldn't blame you, they're as good as it gets as far as customer service and really of all of our sales reps in North America, they're the cream of the crop. So if you want to keep bugging them, by all means, please do that. But I know that for a lot of engineers who are using this tool, they're finding that they can really optimize and automate a lot of their design work, which is the real intention here. So I'm going to pause quickly to see if there's any questions that are coming up in the chat or any questions that people want to plug in. If anyone has something on their mind, something they'd like to see with this tool, I'd love to know. And from there, there's many things that I can show. I'm going to keep talking through a couple cool features of this tool. But if anyone does have any questions, now is a great time to throw those into the chat. And so as I continue here, a few things I kind of would like to note. And probably the first thing here is my unit and inlet size. So the first thing I want to note that's really, I think, functional and worth noting is these are noted as a driven output, but I can easily overwrite and create these an input as an input instead. So I'm going to speak to that. The one other thing I wanted to note is the inlet size here. This is actually an update that we just had come out because we have all of our fan powered boxes in here as well. And all of those fan powered boxes have a casing size and an inlet size. And this is actually a carryover error just that's in this one version, which is getting updated. Really, we only need a unit size for the single deck. So that's one thing to note. I'm seeing a question here from Allison, which I'll address quickly, and then I want to talk about this sizing of boxes here. But Allison asks, is there any way to combine spaces into zones for the Revit add-in? And Allison, that's a great question. Yes, absolutely there is. If you want to follow up with me after and shoot me an email, I'd be happy to show you that at some point. There's another demo which I can do, which is more of an office building, where we would look at, perimeter offices, internal offices, and those internal offices having, very low loads. We can actually couple 3 or 4 of those into a single zone and provide like one single duct for them instead. And in that auto zoning tool, that's something that you can prescribe. What's the maximum amount of spaces you want combined into a zone? What's the maximum amount of zones you want for a single space? That's all stuff that you can play with and determine upstream. So great question, Allison. Happy to address that later. So the other thing here for sizing these single duct units, so this was a yellow column originally, and I just changed it to green because it's kind of like an input output. We do automatically give you a size out of the box in order for you to get as much data as quickly and effectively as possible. However, I could choose to upsize or change these box sizes based off of whatever kind of parameter I want. So I'm going to highlight here in bright yellow this air pressure drop. And something that you might note is a lot of these air pressure drops are above a ½ inch, which I would say in most cases might not actually be optimal. And what you could do is simply overwrite and change these sizes manually. If you wanted, you could turn them into an input. And so I could upsize these boxes. We can see really here quickly. And suddenly I'm in a scenario where, you know, through some upsizing, I can make sure that my air pressure drop for all of my units is below a 1/2 inch. And based off of that, I'm going to see updated leaving water temperature, water pressure drop data. Everything's going to automatically update. So as much as this is an output, this can be an input as well. And I've seen a lot of really creative things done from consulting firms with the unit sizing. I've seen people, you know, for instance, size the unit size. You know, you could insert a column, and maybe you choose to hide these later, but I could choose to do something based off of feet per minute. You know, I could be looking at what's my maximum cooling, what's my unit size, and maybe I want to target getting us close to that 2,000 feet per minute rule of thumb, which is often utilized in industry. You know, 2,000 feet per minute is the point at which airflow creates self-generated noise within ductwork. We often see people try to size the upper limit of single duct boxes as close to 2,000 feet per minute as possible. Maybe your firm uses 1,800 feet per minute, but you could use that to drive inlet size. Maybe you'd like to use a table of values, like a lookup table, and you could do a VLOOKUP to prescribe based off of certain parameters what you'd like for an inlet size. Any of those things is possible. And so as much as, you know, we try to give an inlet size out of the box, that's something that you could update and self-prescribe as needed, really without any concern. Another thing which I would want to note here, which is pretty valuable, is the fact that this is fully dynamic sound data too. So here I'm going to highlight this in just another color just so we know what I'm looking at. And what I'm going to do here is I'm going to modify, for instance, I'll change my liner type to an SM1 liner. And so by changing my liner type to an SM1 liner, what we'll see is my discharge sound is going to pump up, my radiated sound is going to drop. And that's what we see in all cases here. The reason for that is a single duct liner is a more reflective material. So discharge sound, we see that air kind of bounce off with more acoustical energy off of that solid metal liner because it's a less absorptive, a more reflective material. Therefore, we're going to have higher discharge sound, where the radiated sound drops a lot. So these dashes here are below the measurable value of NC pretty much. If you ever see NC19 prescribed, if you've ever prescribed that on a schedule, just know no manufacturer can actually measure that low. 20 is essentially the lowest point that really we can measure. So below that, it is maybe a little bit purposeless, to be completely honest, but you know, no judgment if you've scheduled in that way. But we can see my radiated is dropped because there's so much more material for this sound to kind of break out of. We have all of our liner types here. We have fiber-free liners, solid metal liners, fiberglass liners. So I can change and modify my acoustical data dynamically as required. So even this is a great tool maybe to show data live if you're having conversation or discussion with an acoustician. Another thing which I'd want to note is, you know, FF1, what actually does that mean? Well, we do have a single duct legend that auto-populates here with all of the nomenclature for all of our model codes. A big reason why we use these model codes is because on the downstream side for our sales force, they can actually take these Excel files and they can actually import them into our selection software, which is going to allow for really accurate pricing, fast turnaround times, accurate selections. And so we need that nomenclature there because that's what gets scraped and pulled to kind of insert into our selection software. But for you as engineers, you know, our expectation isn't that you know necessarily all of this info. So as soon as you create a schedule, you're going to get a full code and description legend here for all of our data. Same thing with, you know, attenuators. If you had an electric coil, you know, our SCR option, everything's kind of outlined in here. So that's some good data, a good thing to know for you utilizing this tool. You don't need to be fully versed in our nomenclature. So similarly here, you know, if you wanted to add in an attenuator, That's something you can do. If I drag and drop, we're going to look at our discharge sound here. So I'm going to highlight this here in green. As I add in this attenuator to all of these lines, we can see discharge sound considerably drops because I'm adding an additional section of line duct downstream of the unit to absorb more sound to reduce my discharge noise. So that's fully engineered data here as well to really kind of optimize and fine-tune performance on a case-by-case basis. So, we can even go as far here as I have all of these selections, but maybe I wanted to have a 180-degree entering water schedule instead. It's very easy to make these modifications, one row coils instead. However we want to end up running performance here, we can do all of that live. We can manipulate that data set live. It's a pretty high value tool. Now, one thing I like to show off as well, and I'll just choose something arbitrary here, like for instance, the weights, which is kind of a funny one to choose, but you can also update fully a schedule that you already have with your own data into a price schedule. So I just deleted the weights fully from this cell. So I'm going to zoom in here. I'm going to color this again, make sure we're all looking at the same thing. We'll go for this darker blue color. So what I'd want to show you is I can actually go to this function button in the top left of the screen. I can click insert function, and I can actually go find the price engineering toolkit information here. So let's say I go to terminals, single ducts, and what I'm looking for is weight. This is a great tool that's automatically embedded in Excel that's going to allow me to essentially populate this function in a quick and easy way. So I can choose my model type, which is included, my unit size, which I have here. I can choose my heating coil rows, which is going to obviously drive the weight as well. My discharge attenuator, which I was just playing around with. We can see that ATT option there. Fin density, so that's coil capacity, standard or high capacity coils. My casing, whether it's standard or oversized, and a good example here too, I could just type in standard instead. Has electric coil, true or false, so in this case it's false. And what I could do is I can press OK, and that calculation's back in. And this is something that now I can copy and paste down through my schedule, and suddenly I have all my weights populated again, and all of these weights are driving again. So if I change the size, it's going to change the weight. So you could envision, you could probably turn and flip your schedule just to add, even if you wanted capacity, a more accurate capacity or a more accurate GPM. If that's all you care about, you could just do that. And the important thing to note is you don't have to struggle with it. If you're interested in flipping a schedule to have more accurate data that's dynamic, reach out to Buckley, reach out to me. My email is in the chat. I'd be happy to help convert a schedule for anybody to help optimize kind of the onboarding of this tool. So a couple other things to note in the price industries tab here, we do have information for GRD. So we have grills and diffuser data. So, this is something we're working on optimizing still, but let's say you wanted throw data for a custom flow unit. Rather than going and iterating throw data, you could come in here and, we could get updated data for different delta T's and, all that information that's available here. We're optimizing these right now because there's obviously a lot of models and a lot of data that we're trying to fine tune to make the workflow easier. There's actually some good templating and tools that are available for download on the Price website. We also have in this more information tab, it's going to pull up a little side tab here with a lot of good info. So a competitor cross-reference. Here we have essentially every manufacturer that has operated or is currently operating from the last 50 years, 100 years, with all their product categories and all their model codes. So let's say there's an old Titus model that I'm not familiar with, whatever it may be. we'll have all those models in here. And what you can do is you can go access the price equivalent model. If you click on it, it'll take you to the price website, so you can pull catalogs and submittals, IOMs, whatever you may need. If you click the competitor model, it's going to take you to a Google search, which often the first hit would be from that manufacturer. And so this is a really good tool also for even like a retrofit. You have a customer who has an old building and they want to update certain models, and you're trying to find a modern day equivalent. Come into here, you can find a modern day equivalent. This same tool is fully embedded in the price Revit tool and fully links to all of our families that are available on our website as well. So if you want a competitor cross-reference and you're using Revit instead, you could download the price Revit tool, and you're going to be able to save and favorite the families you utilize most often. You're going to be able to use the competitor cross-reference and pull a model directly into, pull a family directly into your Revit model as well, quick and easy. So that exists here. That's a good thing to note. Also in the more information tab here, you can see we do have an updates log here. The main reason why I want to point that out is this is a in-house price generated, price managed, price created software tool set. So we have created this with actual price employees who are computer engineers. We didn't, outsource this from elsewhere. This is a price made tool. So if you're needing support, for instance, if you go to this contact us and you go to support@priceindustries.com, that goes into a shared inbox for like 20 computer engineers, and someone's going to pull it from there and get you help right away. Similarly, if you wanted to get help from something and you reached out to whoever you know from Buckley best, you should give them a shout. They're going to have a contact for someone at Price who can actually go in and fix the issue, diagnose what's going on. We can give fast answers, fast turnarounds, because this support is actually going to the people who made and coded these tools. So with that being said, I want to head back over to Revit. I want to show one last tool off, and this tool takes a little bit longer to run sometimes in this context. I want to give a bit of a teaser to it though, because it's a pretty fun one that can save a lot of time. And as this is loading up, I'll answer some more questions in the chat. So if anyone has other questions about how to integrate this, if anyone wants to also shoot me something offline, my email is in the chat. But the other thing I want to show off is this air terminal selection placement tool here. And so the real intention of this tool, in my view, is to provide high value estimating for Revit, for GRD. So imagine you're getting close to needing to release a 50% DD set or something like that. And even if it's earlier in the process, at some point you need a drawing set. The construction project manager is asking for a budget price of whatever it might be, dollar per square foot for HVAC, and you need to make some quick selections. And normally you'd have to go in, drag and drop every single GRD into the ceiling, connect it to the ceiling, snap it in, whatever you might need to do. It's a time-consuming process. The intention of this is to cut down on that design work by auto placing and auto sizing GRD into the ceiling for you. So currently we have it set up with square plaque, square cone, and per face diffusers. Once again, all Price Revit families that are automatically embedded within this tool. And what you're going to be able to do is you're going to set some parameters here about CFM, noise criteria, and total pressure drop that I want. And I can set all three of these parameters and I'll maximize a selection that can hit those. I can also add in alphanumerics here. So I could, if this was 630, which I want to keep. This was, if I change that to 630 NA, it's going to block out and not allow for a size 12-inch neck. If I have, any kind of data in there, it's going to optimize in size based off of that data. The same thing for return diffusers and exhaust diffuser selections as well. Then this is going to essentially, once again, scrape all of the data from your space types. So supply, exhaust, return air decisions. It's going to look and see if there is a ceiling or not. If there's no ceiling, it's automatically going to place a round cone diffuser, which is much more optimal from an air distribution perspective, because we don't have the benefits of the Coanda effect of the ceiling. And what I can do here is I can select all my spaces in my entire model. And this is going to know whether it's a supply or a return diffuser. And what I'm going to do is I'm going to place air terminals. And so this will take a second to chug through, because what's happening is every single space is essentially doing ASHRAE 55, ADPI type, flow collision detection stuff, auto sizing for NC, auto sizing for airflow, optimizing throw, trying to make sure we get that 50 feet per minute once it actually hits the occupant in the occupied zone. It's essentially doing, the drawing of that 8-foot diameter circle around every single GRD, making sure there's no clash detection. And what it's going to do is optimize that for both supply. It's going to optimize that for my return as well. And it's going to auto snap those into the ceiling for every single space. So I'm seeing a question here, which I'm going to address. Sometimes this takes a little while to run through on my computer, especially when loaded up to do some selections. So that's why I wanted to get this started and running. And I'll answer and address some questions here. So I'm seeing another question from Bradford. I have to say, Bradford, I appreciate your engagement. Thanks for all the great questions in this session here. Regarding the Revit tool, not under your control, but typically the architect is the proper setup of the model and assignment of the rooms, spaces, zones. Unfortunately, this isn't always set up correctly in the early design phase, something we need to be on the same page about during the design. This is what I call garbage in, garbage out, Bradford, and I agree with it. I see it all the time, and it's one of the most common comments about the utilization of this tool. Garbage in, garbage out. What if I get a terrible architectural drawing set? You've identified a major concern, and that is a reality that we need to work through with architects to make sure we have accurate drawings to try our best to move forward with designing the space. And I'll say this, and this is probably my main comment. I would say working with the architect or even assigning some spaces yourself, if you're able to get a budget number, would actually be a lot faster of a process than actually snapping in and dragging and dropping all the GRD automatically or manually by hand. Similarly for the VAV boxes, it'd still be a much faster process to assign some of that data rather than going in and doing all the manual selections and design work. Now, that's not true in every case. And in some cases, if that is not true, absolutely you may choose to maybe only utilize this tool for where it works. You can still modify and manually place stuff after the fact and drag stuff around. So I like to even see sometimes this tool get used. You see it kind of optimally do as much as it can, and then you manually move on from there. And that can still provide, I think, a lot of value to a project. It's true. If your architectural ceiling in your set is 3 inches off the floor and all the spaces aren't named and the square footage is wrong, of course that's going to be a major concern for the accuracy of the design as well. But that's something I'm sure you would battle through on your end regardless. Any other questions in the chat here as this continues to load up? I believe this is selecting and auto placing about 310 GRD. We had another version of this webinar on Tuesday, and I think it took maybe about 3 or 4 minutes to do it. It feels like a lifetime when you're sharing your screen in a presentation context, but I think probably in my experience, doing all these selections by hand is probably about a day of work. So it's still moving a lot faster than maybe what we would typically see. So this is going to keep going. And it's not broken, it is working. It just is a fair bit of data, especially for my computer, which my slim HP EliteBook is the fan screaming at this point. Bradford, I appreciate your comment here too. Yeah, complaining, I don't think it's complaining, more like venting. I'm with you. It is a struggle if the architectural drawings aren't providing the value to the project that we need for selections. Hopefully, maybe that's an opportunity to pivot instead to utilizing Excel instead. So we're going to see this come through with this selection here shortly. And maybe in the interim, as this is kind of plugging through, I do want to show a couple things off for support purposes that we have on the website here. So I'm just going to drag this off to the side as it's doing its thing. So a couple things I'd want to note. Everything can be downloaded off the Price website. You know, we do have the toolkit for Revit. So this toolkit for Revit is the competitor cross-reference tool, which I referred to, full cross-reference, full embedded price families. We have all the price product families automatically embedded as a menu. So instead of the standard Revit families, which, you know, at times are accurate or inaccurate to actual sizes, you know, this is going to allow you to use everything from price from chilled beams to terminal units to fan coils to GRD. You know, it even has, in some cases, Revit families that we would have for louvers. I'm seeing this, it's chugging through. I think it's actually almost done there. And also a favorites tab, which is going to allow, let's say, use our custom flow, which is, you know, like our improved updated slot diffuser set. You could use that as a standard family, have it ready to drag and drop in for your model. So that's available for download. That's free. That's there for you and your utilization. We have the toolkit for Excel too. So water coil, GRD terminal units, which we discussed, which is probably the biggest one. And we have training material in here, which I'd want you to know is available for utilization for kind of optimizing your workflow there. A great thing to reference. And then finally, our Ripple HVAC toolkit, which Ripple was created in conjunction between Price and then Kevin Lawson, who was a consulting engineer who lives still in California, has worked in California for a long time. We found some of his productivity tools were really impressive, so we created a marketing partnership together that uses all of the Price performance, some of his ideas and tools, and we've collaborated to create these auto placement tools, which everyone's finding so functional and so exciting. Oh, and we can see here, it is chugging through. You can see almost all of these GRD units have been placed. It looks like it's doing a little bit of final chugging and calculation here, but this is the kind of thing that we're seeing with this tool. As we're gonna see all of this GRD optimally placed within the zone. And sorry, it is taking a second here, but it is a lot of work that's being created pretty quickly. And so, yeah, I think as a budgeting tool, I find that this is really high value. I think you guys would probably find it functional for, you know, early design decisions, even just optimization of stuff. I want to click around, but it's still doing its thing, which when you have too many things open at once, there we go. So we can see some of the selections done here. So I'll go highlight a certain zone. We can see round cone diffusers placed in the areas with no ceilings. If I go down to these zones below, we can see some optimally placed diffusers as well. So these are auto-sized, size 10-inch inlets in this case. And so all of this material is auto-sized and placed. Obviously, this is material where I can go change and modify this family, update it as desired. But this is automatically aligned with the ceiling. And you know, from here you could even get into some of the productivity tools within Revit that automatically create and space out some ductwork. But even at this point, you'd have a pretty accurate budget number, even if you just dropped in your main kind of branch ductwork and went from there. So that's kind of the majority of what I wanted to show off in this demo. If there's any questions, I would love for them to be added to the chat. If there's any further questions, you could get with us downstream. We'd be happy to have more conversation about this tool and how it works. You can see even for this GRD, it kind of subdivides some of these zones smaller individual spaces to make sure that we get diffusers in all the nooks and crannies to really mix this space optimally and not throw too hard against any individual wall, or not to have any flow collisions or anything like that. So that's really it for me. Once again, my name's Mark Mann with Price Industries, Project Engineering Manager for Air Moving Products. If there's any questions on these tools or anything else we have as far as irons in the fire to help improve productivity for the consulting engineer, I'd love to have a conversation with you about it. If you're interested in training for your office or sharing this with anybody else, reach out to Buckley and we'll schedule some training with Price personnel. And we can't wait to hear from you. Hopefully you can all find use for this. And thank you for attending and thank you for your engagement.